A black hole can trap light, slow time, bend space, and tear apart stars, and somehow that is still not the weirdest thing about it. Because the strangest part is not what a black hole does, it is what a black hole is. Most people picture a black hole the wrong way. They imagine a hole ripped into space, a tunnel, a drain, a mouth, something empty waiting to swallow whatever gets too close. But a black hole is not really a hole like that at all. It is what happens when matter gets crushed so completely that gravity stops acting normal, space bends, time changes, escape stops being possible. That is why black holes do not feel like objects. They feel like mistakes the universe decided to keep. The line around a black hole is called the event horizon. This is the point where getting out becomes impossible. Not hard, not unlikely, impossible. Even light cannot escape once it crosses that boundary. And that matters because light is not slow. Light is the fastest thing in the universe. It is the speed limit. So if even light cannot get out, then a black hole is not just powerful. It is extreme in a way human instinct was never built to understand. And the event horizon makes it worse because it is not a wall. It is not a shell. It is not some hard surface floating in space. It is more like a border written into reality itself. Cross it, and every path leads inward. The future only points one way. That should bother you, because for most things in the universe, the rules still feel stable. Planets orbit stars. Stars burn fuel. Galaxies spin. Even when something violent happens, like a supernova, you can still follow the logic. Pressure builds. The core collapses. Energy explodes outward. Cause leads to effect. Black holes feel different. They feel like the point where logic stops feeling safe. And yet, they are real. Some black holes are born when giant stars die. For most of a star's life, there is a balance. Gravity is trying to crush the star inward. Fusion in the core is pushing outward. As long as those two forces stay balanced, the star survives. But eventually the fuel runs out. The outward push weakens. Gravity wins. The core collapses inward with unbelievable force. If the star is massive enough, nothing can stop that collapse. No gas pressure, no radiation, no known force in nature. The star does not just die. It leaves behind a place where escape itself no longer works. That alone is enough to make black holes unforgettable. A dead star collapsing into something so dense that even light cannot leave already sounds like the kind of idea science should have rejected as too dramatic. But black holes do not stop there. At the centers of galaxies, including our own, there are supermassive black holes. These are not just a little bigger than stars. They can hold the mass of millions or even billions of suns. That means black holes are not rare accidents hidden in the dark. They may be part of the universe's basic structure. Entire galaxies may form, grow, and change around them. So a black hole is not just a cosmic disaster, it may be one of the main organizing forces in the universe. And then we get to the part that really breaks your brain: time. We live as if time is steady. 1 second is 1 second. A clock ticks and the universe agrees. But near a black hole, that idea starts to fall apart. Einstein showed that gravity and time are connected. The stronger the gravity, the slower time passes compared to places farther away. Near Earth, this effect is tiny. Near a black hole, it becomes brutal. If you watched someone falling toward a black hole from far away, you would see them slow down as they approached the event horizon. Their light would stretch, fade, and grow redder. They would seem to freeze near the edge. But from their own point of view, they would not feel frozen at all. Their thoughts would still move. Their heartbeat would still continue. They would keep falling inward. Both of those versions are true. That means a black hole does not just trap matter. It traps your basic trust in time. Then comes the part with the ridiculous name and the horrifying meaning: spaghettification. If you fell feet first toward a black hole, gravity would pull harder on your feet than on your head. That difference is called a tidal force. Near some black holes, that difference becomes so extreme that your body would be stretched longer and longer until it was torn apart, not crushed at once, not smashed against a surface, pulled unevenly until your structure failed. This is what makes black holes feel so unnatural. They do not need teeth. They do not need fire. They do not need a surface to kill you. Space itself becomes fatal. And somehow, that is still not the strangest part. Because the darkest objects in the universe can also create some of the brightest things we have ever seen. A black hole itself gives off no light from inside the event horizon. That is why it is black. But the material falling toward it often forms a fast-spinning disk around it. Gas, dust, and torn-apart matter slam into each other as they spiral inward. They heat up to incredible temperatures. They glow, they blast out radiation. Some black holes even launch giant jets of matter outward at nearly the speed of light. So the thing famous for swallowing light can sit inside a storm bright enough to outshine whole galaxies. That is not just strange. That is upside down. This is also why black holes were so hard to prove. You usually cannot see the black hole directly. You see what it does to everything around it. You watch stars orbit something invisible. You see gas heated to impossible temperatures. You see light bent and twisted in ways that should not happen unless something massive and hidden is there. For a long time, black holes were tracked like invisible predators. Not by seeing them, by seeing what survived being near them. Then, in 2019, humans did something that almost sounds impossible. Scientists released the first image of a black hole's shadow. They linked telescopes across Earth into one giant observing system and aimed it at the supermassive black hole in a galaxy called M87. What they captured was a glowing ring around a dark center, not the black hole itself, the scar it cut into light. Later, they revealed an image of the black hole at the center of our own galaxy. Think about what that means. A species on one small planet, orbiting one ordinary star, managed to detect the outline of something that does not even let light escape. For centuries, black holes sounded like theory, metaphor, maybe even myth. Then suddenly we had evidence staring back at us. But that only showed the edge. The real mystery is deeper. Because at the center of a black hole sits the place where our best physics starts to fail, the singularity. According to our current equations, matter inside a black hole may collapse so completely that density becomes effectively infinite and space-time curvature becomes extreme beyond what the math can sensibly describe. In physics, that is usually a warning sign. When infinities start appearing, it often means the theory has hit a wall. The model is no longer enough. So when people talk confidently about what is happening at the exact center of a black hole, they are usually speaking beyond what science truly knows. The honest answer is much more unsettling. We do not know. And that is a huge reason black holes matter so much. They are not just weird objects in space. They are places where our deepest theories stop fitting together properly. General relativity explains gravity brilliantly on large scales. Quantum mechanics explains the tiny world of particles with astonishing precision. But black holes force those two systems into the same extreme conditions, and right now, they do not fully agree. That means black holes are not just part of astronomy. They are one of the biggest unsolved problems in reality. Then comes the question that has bothered physicists for decades. What happens to information? In physics, information means the deep details that describe what something is and how it is arranged. Quantum theory says information should not simply vanish. But black holes seem built to hide things forever. Then Stephen Hawking made the problem even worse by showing that black holes may slowly leak energy through what we now call Hawking radiation. If that process continues long enough, a black hole could eventually evaporate. Now the nightmare gets bigger. If the black hole disappears, what happens to everything that fell in? Is the information destroyed? Is it stored somehow on the event horizon? Is it preserved in some form we still do not understand? This is not some side puzzle for specialists. If black holes truly erase information, then some of our deepest laws of physics may be incomplete. So black holes are not just dangerous. They are embarrassing. They expose the limits of human understanding. They take the rules we trust. Light escapes, time flows evenly, information survives, and they force us to admit that those rules may only work in the quiet, familiar parts of the universe. And still, black holes may help shape creation itself. Supermassive black holes can influence how gas moves through galaxies, how stars form, and how energy spreads across enormous distances. A thing known for swallowing may help organize. A thing defined by darkness may shape where light is born. That is what makes black holes so hard to hold in one thought. They destroy, but they also structure. They hide, but they also reveal. They break the rules, but they may be the key to discovering deeper ones. Most mysteries become smaller when science explains them. The unknown becomes a mechanism. The monster becomes an animal. Fear becomes a system. But black holes do the opposite. The more you understand them, the less comfortable the universe starts to feel. They trap light. They slow time. They bend space. They can tear apart stars. They may evaporate. They may contain clues to a deeper theory of reality that we still do not have. And the edge of one is not made of rock, gas, or fire, but of a boundary written into space-time itself. That is why nothing about black holes is normal. Not how they are born, not how they bend time, not how they treat light, not how they expose the weakness in our best theories, not the fact that the universe allows them to exist at all. They are not just holes in space. They are places where reality folds inward, closes behind you, and refuses to explain what happens next.